In today's video, let's talk about alkane. Alkanes are organic compounds that consist entirely of single-bonded carbon and hydrogens. They lack any other functional groups. Alkanes are saturated hydrocarbons and are the simplest and less reactive of all. Alkanes only undergo two types of reactions: combustion, which is a reaction between hydrocarbons and oxygen, and the product is always carbon dioxide and water. They also undergo free radical halogenation, which is an example of a substitution, and you will see this reaction named as chlorination or bromination. This reaction is divided in three steps: initiation, propagation, and termination. Let's focus on free radical halogenation for a second. Free radical reactions generally require heat or light to be applied. That is because either of these energy sources can lead to a homolytic cleavage. This homolytic cleavage of relatively weak bonds, like between chloride and chloride, to give free radical to each other. Every free radical reactions begin with a step where free radicals are created, and for that reason, this initial step is called initiation. There is two things that you need to know. The reaction is at equilibrium. At any given time, there is only a small concentration of the free radical present, but this will be enough as well. The second thing that you need to know is that there is a net increase of free radicals in this reaction. We're going from 0 to 2 in the product. As we can see, there is a net increase in the number of free radicals. So this is an example of initiation. For the DAT, just look where the radicals are. If you see the radicals as the product, you might right away in 2 seconds pick initiation. The second step is propagation. This only occurs when you see the free radicals or the free radicals are present. Radicals are in the reactant and in the product, so it's easy to be identified. For the DAT, they will only ask you to identify which of these reactions represent initiation, propagation, or termination. And you will only need to pick which one represents each of them. So it's easy for you to learn how to differentiate where the reactions, where the radicals are located, and pick accordingly. But let's talk about propagation and give you a foundation about what this means. As you can see, after the bonds are broken and bonds are formed, you will notice that you have one radical in one side and the other one radical is in the product side. You will have an equal amount of radicals on each side. That is simply propagation. For termination, you will notice that the number of free radicals have decreased. But also notice in an easy identification that you will see the radicals only found in the reactant side. As you can see here, you can only see radicals in the reactant side. Okay, let's overview and see a easy identification and faster identification for initiation, propagation, and termination. The way that I like to see it is that initiation means the opposite. Initiation means the end. Propagation means in both sides. And termination means at the beginning. So I see this word initiation and termination as opposite words of each other. And propagation only means both. The radical stability goes from allylic, tertiary, secondary, primary, and a methyl. If you're not familiar with allylic is nothing more than one away from a double bond. Best represented this way. Radicals contain a single occupied orbitals. They are neutral, highly unstable, this meaning they are very reactive. Remember that the region for these reactions are either bromide, in He or Li, and chloride, in He or Li as well. Please note that bromination is very selective. It will always go to the side that is most substituted. Chlorination in the other case is non-selective. This meaning that with chloride we get all possible products. On the D18 you see an alkane. Please immediately add chloride or bromide to the most substituent carbon and you will be done. The only difference between bromide and chloride is in free radical halogenation is that Br will always add to the most substituent carbon, but chloride, on the other hand, can add to any and can therefore produce multiple products. But the product with the most stable radical intermediate will be the major product.